Welcome to lesson 20. In this lesson we will learn how to process real numbers. A real number is a decimal number. Decimal numbers are also often called floating point numbers. An example of a real number is the value of pi. Pi's value is 22 divided by 7, which results to 3.1415927. And in the case of pi, the digits after the point just goes on and on. It is very common to get a real value as a result of a division. That is because a division can break a whole number up into fractions. An example is 3 divided by 2. This calculation yields 1.5, which is a real value. When we work with currency, we also use real values like rands and cents, dollars and cents, or pounds and pennies. An example is 25 rand and 40 cents, or $8.25. When writing these amounts, we use a decimal point to separate the cents with the rands or the dollars. Real numbers are also commonly used in scientific computations because they provide better precision than a whole number. In this lesson, we will only look at simple calculations that produce real numbers, but in a later lesson we are going to do more advanced stuff. In many cases, the real numbers that we get as a result of a calculation must be displayed to our users as output. When we display output, we normally display it as text in the caption or lines properties of components. By now you should already know that these properties only accept string values. Just like integers, you must also convert a real value to a string before you can display it as a string output. Let's look at this example. If you have the value of pi, which is the number 3.1415927, and you want to assign it to a string property, you must first convert it to a string. This can be done by using another one of Delphi's built-in functions called the FloatToStr function. Remember, I mentioned that a real number is also known as a floating point number. The FloatToStr function receives the real number as an argument and then converts it to a string. The result can be assigned to the caption property or added to the lines property. Let's go back to Delphi's IDE again and try this out with a practical example. I still have the age calculation program open in my copy of Delphi. We will make a few changes in this application for this exercise. First, let's drag the bottom edge of the form down a little bit. Add another panel in the extra space you created and position it under the existing light blue panel. Remove the new panel's caption and change the new panel's name to P&L average age. This panel must display an average age for Mary and John. In other words, when you click the calculate button, your code must add the ages and divide it by 2. It can happen that the average is a decimal number. For example, if Mary is 20 years old and John is 5 years old, their combined age is 25. Therefore, the average will be 12.5 years. Let's go and add more code to the calculate button's click event handler to illustrate this. Double-click the Calculate button. Delphi takes you to the click event handler for BT and Calculate that was created in the previous lesson. Under the code that you added in the previous lesson, type another comment. It must read display average age in P&L average. On the next line, type P&L average age dot caption followed by an assignment operator. Because it is very likely that the average age will be a real value, we must use the FloatToStr function. Type FloatToStr followed by an opening bracket. After the bracket, type sed Mary's age dot value followed by a plus. After the plus, type sed John's age dot value. After that, type a forward slash. The forward slash is a division operator. To work out an average, we must divide the sum of the two ages by 2, so type a 2. Type a closing bracket followed by a semicolon to end this instruction. Now let's read this instruction from the back to analyze it. Here I instruct Delphi's compiler to add Mary's age with John's age and to divide it by 2. There is a problem with that expression, but we will get back to that later. Then we take the result, which is most likely a floating point number, and we pass it as an argument to the FloatToStr function. Just like the int-to-string function, the float-to-string function encapsulates its own code to convert the real to a string. You do not have to know how it is done, you only need to know how to use it. The converted value is now a string and can therefore be assigned to the caption of the panel named P&L average age. Let's run the application to test our code. Click the Run button in the speed bar, change Mary's age to 20 and change John's age to 5. The combined age that must display in the blue panel must therefore be 25. 25 divided by 2 is 12.5. So the grey panel must now show 12.5. Let's see if our calculation works. Click the Calculate button. The blue panel works. It displays combined age 25. The grey panel displays 22.5. That's not right. 25 divided by 2 is 12.5, so the grey panel must show 12.5 and not 22.5. Delphi also doesn't complain about this error. If you get unexpected results like this, it is not because you made a language or a syntax mistake. The mistake is in our logic. This is called a logic error. Let's go and figure out why we don't get the correct result. Close the form. Let's look at the expression that we pass as an argument to the float-to-string function. Maybe you've already learned how to apply BODMAS in maths. With BODMAS you learn that mathematical expressions are processed in a specific order. We refer to that process as the order of precedence of arithmetic operators. That is a mouthful, but you will learn more about that in a future lesson. For this example I'm going to keep it simple. What you need to know for this example is that the division has precedence over an addition. This means that the compiler will first divide John's age by 2. So if John is 5 years old and the compiler divides 5 by 2, the result is 2.5. If Mary's age is 20, the compiler will then add the 2.5 to 20 and the result will therefore be 20 plus 2.5, which is 22.5. And there we figured out why we get the wrong result. It is because the logic in this calculation is wrong. We want to first add Mary and John's ages and then we want to divide the total by 2. In other words, we want to add 20 to 5 to get 25, then we want to divide 25 by 2 to get 12.5. To tell the compiler to do the addition first, we must enclose the operation that's doing the addition in brackets. Let's go and do that. Put your insertion point after the opening bracket of the float-to-string function and sed Mary's age and type another opening bracket. Now put your insertion point before the division operator and type a closing bracket. Because this operation is now between brackets, the compiler will see that you want to add the ages first before doing the division. Let's test our code again. Click the Run button in the speed bar. Change Mary's age to 20 and change John's age to 5 again. Remember, the correct average is 12.5. Let's see what we get. Click the Calculate button. The grey panel now shows 12.5. The number 12.5 is not a real anymore. You converted the number to a string before assigning it to the caption property of the panel. If that number is really a string, we must be able to concatenate the value with other string values. Let's try that. Close the form. Put your insertion point between the assignment operator and the float-to-string function. Type average age, enclosed in inverted commas, followed by a concatenation operator. If you want to, you can also put a part of this instruction on the next line so that you can see all the code. Now let's analyze this instruction. We tell the Delphi compiler to pass the result of an expression to the float-to-string function as an argument. The compiler must do the plus operation first and then divide that result by 2. The float-to-string function must convert the result to a string. Then it must concatenate that string value with another string with the words average age. This whole concatenated string must then be assigned to the caption property of the panel called P&L average age. Now let's test this code. Run the application, change Mary's age to 20 and change John's age to 5 again. Click the Calculate button. The panel now shows average age 12.5. So our concatenation was also successful. These calculations are very simple, but it provides you with the fundamentals that you will need for more complex computations. Like I said before, you will learn how to work with more complex scenarios in the future. In all our lessons so far, we only added code for click event handlers of buttons, but Delphi components have many more events. In the next lesson, we will explore the structure of events and we will write code for more events. I'll talk to you again in lesson 21.